Hey guys, welcome to DevOpsSchool. Kubernetes is one of the most popular technology in cloud computing as of today. Learning Kubernetes is essential for any DevOps professional, and one of the most in-demand certification is Kubernetes Administration. In this session and in this series, we are going to learn various aspects of Kubernetes Administration, which will help you to prepare for the Certified Kubernetes Administration exam or CKA exam. This series is divided into 20 parts, therefore subscribe to our channel and follow the playlist for complete understanding.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOpsSchool certification level courses, which will help you to emerge skills for a wide range of entry-level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai, and in Pune. Simply compare our many courses, find the one that suits your style and schedule best, and start today.
Yeah, so basically, yes, we have discussed in the last session. We have a master, and we have worker, and then we have workstation. Workstation is owned by human, the person who's handling the entire cluster. So from the workstation, he will write a package. I will teach you how to write a package, deployment package in JSON and YAML. So he'll send it to the master. Master, you have a 4 component: API server, cluster store, controller manager, and scheduler. So all 4 of which it works together and manage the cluster, entire cluster. It may be 1 node cluster, which may be 500 node cluster. Kubernetes can manage it, and that is how it is. So today we will focus on worker, right? So let's get started.
How many workers are possible in one cluster? I mean, how many nodes Kubernetes support in a cluster?
There is no as such data is out, but some matrices depends on the experience, depends on your basically deployment, number of deployments, number of services, and number of what if you have a CRD's custom controller also. This may you can plan it out, number of nodes.
I do understand what you say, but I mean there should be some best practices, like how many nodes do you want to put in one cluster? Is there any recommendation by Kubernetes, or is there any best practice?
There are few recommendation in terms of not number of nodes you should be putting for the one cluster, but there is a recommendation for that. If there is a number of nodes which is available, what is the ideal CPU size and RAM size which you should have it in the master? So that is those are the kind of things are there. So I'll share with you those URLs, which is an official documentation after this discussion.
Okay, thank you.
Okay, so let's get started, guys. So here we are going to discuss about nodes, aka minions, aka Kubernetes worker, right? So here minions, aka worker, aka nodes, we have a 3 important component, okay, in the worker.
Rajesh, what does aka stand for? AKA.
Also known as.
All right, okay, thank you.
Yeah. So here, yes. So here in the worker node, or you can call it minions, or you can call it node also, you have a 3 component, and this is what we are going to discuss now. Now, first component is Cubelet. Okay, Cubelet. So what is a Cubelet? So a Cubelet is basically an agent which is inside a node, and it has to run. Remember, it has to keep on running. Okay, Cubelet decide and register a node with a cluster. Cluster means master. Kubelet also watches API server. Okay, this guy also always running and watching the API server. And if it's not running, that means this guy is not existence for the cluster. Kubelet instantiate a pod. Remember, there are two things which we have understood. Based on the API server request, scheduler schedule the nodes, pods inside a node. And here initiation is done by pods, but done by Kubelet. Now the work has been done, report back to the master, and typically it runs on the 10255. Okay, this is a Kubelet. So let's put it in this some perspective, so you will always remember the Kubelet. Kubelet is like a minion. Okay, minion. I'm sure you might have watched this movie from last 1 week. So minion is a kind of species which is very sad if they are not having any master, correct? So they get up and look for the master. Yes, minions gets up. I'm sure you might have watched this movie. Minions gets up in the morning and they look for the master and they become sad, right? So same way, Kubelets also gets up. Kubelets gets up means Kubelet, when you run a kubelet, that's called Kubelets gets up. So Kubelets gets up, Kubelets run and look for the master. Now the question is, minions look for the master where? Minions look for the master in his own world, right? So now the question is, now the question is, what is the world of Kubelet? So world of Kubelet is the node, machine or server, whatever it is, physical machine or virtual machines. That is the world, right? So it will look for the master. Kubelet look for the master to some configuration file, which we call it a kubelet.conf, which is located at one place, which is under the etc Kubernetes, some locations. So in that they get the master address. Now the question is, master address means what? So basically it gets the API server address. Remember, API server is the front end for the entire cluster. Nothing, no communications can escape it. So everyone has to go through the API server. Yes. So here, when I say here, Kubelet look for that file and register a node with the cluster. Same way, minions travel the whole world and look for the master. Okay. The moment minions find the master, minions beg to the master saying that, okay, you become my master. Same way, when Kubelets find it API server, Kubelet request API server, I want to be your worker, I want to be your node, I want to be your minion, I want to be your slave. So when its automatic process happens, I'll show you in the demo time. So the automatic process happens, whereas when node Kubelet request to the API server to have a membership of the worker, then by default there is some token which is provided by API server. So based on that, they approve the request. So same way, minions request to the master, a master approves the request. Master can deny also. Same way, API server can deny also. Remember, okay, there's a flexibility. So here, my API server can decide which is worker, which is not worker. All these things can be possible. So same way, master can decide deny. But here I will not take that example. So here, minions request to the master, Kubelet request to the API server, and request to become a part of the family of worker or minions, the slave. Now, the moment master accept it, okay, you are my slave now. That means the moment API server accept that request, then minions keep bugging the master. You know the movie, right? Minions keep bugging the master, saying that master, give me the work, I'm alive, I'm having this much of CPU, I'm having this much of RAM, I'm having this many ports and stuff like that. Keep bugging them, always bugging the master. But master only give the work only if he's having it. So same way, Cubelet also keep bugging the API server, keep watching the API server. And if API server has a request for it, then only it will give it. By the way, just imagine who's passing the request to the kubelet in the node. Any idea who's passing the request through the API server to the node? Scheduler. Yes, you got it. Every communication happen through scheduler. Yes. So when a scheduler assign the work to the node, again it is done through API server. Remember, most of the time we feel API server is one component. No, it has a multiple endpoints. API server is a server of multiple APIs. Okay. So yes. So the moment Kubelet receive the request from the master, that means from API server through scheduler, then Cubelet instantiate a pod. Again, understand that, instantiate a pod. Scheduler schedule the pod into the node to the node, but here Cubelet instantiate a pod. In a simplified manner, if you want to say, create a pod. Now here again, once the pod has been created by Cubelet, it reports back to the master, saying that minion saying that master, I have done your work, please give me more work. Same way, Cubelet will inform the API server saying that I have completed work or not completed work. Okay, so this is the Cubelet, this is a minion, this is the minion versus master, this is the Cubelet versus API server. Did you understand this component? It always run. If it is not running, let me tell you, if the minion is not alive, then it's worthless for masters, right? So same way, if Cubelet is not running in the agent, in the work, in the virtual machine, in the server, it is not worth it actually. So it has to be running all the time. Understood this?
Yes, Rajesh, this is what is understandable. But the question is, are there any parameters on which a kubelet request to the master, give me some work, and master denies, or master accepts the request? So these parameters of acceptance or denial from master, where do we define them and how are they defined?
Yes, so it's like this. When I set up a cluster, I'll show you the node. I mean demo basically. So in that at that time, I will show you one token. Okay, a token. So any node who's registering a node with a cluster, and if his request is going through the token, then automatically API server will accept it. In a simple way, if I put it up, let's say you are the employees of your company. I am also working for the company, but I am a guest. So if you go to the company, you have already the employee's ID with the access card, and I am a guest, I don't have. So if I don't have, then I have to go to the reception and get the special permission to go inside the office. Now in your case, if you have already the ID card, and in that case you can go directly without talking and asking anyone. So it's like that. When you set up a cluster, I'm saying the cluster, then at that time cluster itself would release one particular access token, and if anyone uses that token to register a node with the cluster, automatically the certificate will be shared and the master and node communication will be established. Make sense?
Yeah, it does indeed. Thank you.
Yeah. So now the second thing is container engine, and for that I'm not going to talk about it because we have spent a lot of time on that, right? So container engine, you know that Docker, but the beauty of the Kubernetes is you can have a other container engine also, like a Rocket, CryoD, Containerd, and many other container engine. In fact, Kubernetes has their own container engine, so you can have all this stuff. I have shown you in the previous session also. The one of my blogs where you can see the number of container interfaces which you can use it. By the way, this is a little bit old blog. I think it was 1 year old, but from last 1 year there's so many stable release in the container interface has come. So yes, if you don't like a Docker tomorrow, you can change that, and that's one of the beauty about this. So by the way, yes, default container engine is a Docker for time being, and Docker you know very well. So second component which you can find in the each of these worker node is a Docker. Now with that, let me remind you, if you have forgotten, let me remind you why we are using Kubernetes. One of the reason what we had was to access the container through some way. Understand that. Again, read my line. One of the requirements why we had a Kubernetes was like to access the container some way outside of the host to the load balancer and without changing the port. Remember, without changing the proxy port, without doing the proxy port, right? That was one of the challenge, because if you run multiple containers in one host and if you change the each port to access outside, it load balancer will not work, right? So remember, that was the problem. Yes, so that was the problem which is Kubernetes is solving it. So yes, Kubernetes states, okay, any software, any driver, networking driver or networking policies which satisfy these three requirements, I will help it. I will help you in doing. I'll help you and I'll accept as a network driver, network policies. So now the question is, this is the three questions what Kubernetes has it and which states Kubernetes networking requirement. Here, all pod. Right now, the question is, what is a pod? We have not discussed, but let me remind you, we have stated very clearly. API server request for the pod to scheduler based on the actual versus desire, okay, by the human beings in the cluster. Scheduler schedule the pod to the node. In the node, you have a kubelet which is running all the time. Kubelet instantiate a pod. Pod has a container. Pod may have multiple container. This we have discussed so many times, but still we have not discussed what is a pod, which will come back. But right now, remember, if the pod has a container, that means my application is running inside a pod. So Kubernetes networking requirement, there are three rules. Please hard code with this three statement. All pod, understand that all pod can communicate with each other on all nodes. Yes. In a Docker, if you have multiple Docker hosts, you cannot do that. But here, what you have to do, all pods can communicate with each other on all the nodes. That's the first requirement for the Kubernetes networking. Here, second requirement is all nodes can communicate with all pods. Think about it. All nodes can communicate with all pods. That's a wonderful thing, right? And no network address translation is required. No natting. You cannot allow natting. The one which we did in the Docker session, which using -p option, if you remember, and you were not able to -p with the two container with the same port. Anyone remember that one?
Yes, Rajesh, I do.
Yeah. So here, this is the three requirement. Now the question is, who will make it these things possible? Who will make it this thing possible? These are the requirements. No. And this is the things will be make it possible with the help of kube proxy, which is there in each worker, each minion, each node. So now guys, kube proxy is an application which will make it happen. All ports can communicate with each other on all nodes. All nodes can communicate with all ports, and no network address translation is required. So who will make it possible? Kubeproxy, which is the third component of the worker. So what is a kubeproxy? Kubeproxy is a Kubernetes networking services. Okay. Now it allocate the IP address to the pod. Here you look at this again. I'm saying here, kubeproxy allocate the IP address of pod. Yes. Here container do not get IP address. Who will get the IP address? Pod. Now I told you very clearly, pod may have a multiple containers. So statement states all containers in a pod share a single IP. Yes. Remember, if you have gone through my discussion on Docker, container is nothing but just a mere process. You can keep it multiple process together and in a one kind of wrapper, and that we can call it a pod. And that pod get an IP address using kubeproxy. And because a pod gets IP address and also helps, kubeproxy helps you to satisfy all three requirements, it pod can be load balanced. Again, not container. Pod can be load balanced across all the pods in a service. What is a service? I'll talk about it. And what is a pod? I will talk about it. But because of kubeproxy, your networking has been implemented and all this networking requirement has been satisfied. Make sense?
It does, Rajesh, but one thing is a bit confusing, that if a pod can have multiple containers, and we've introduced another layer of networking, which is wire kubeproxy. So say one pod has two containers, will they have the same IP address? Then how can we distinguish between them?
So how can we distinguish between them? That's the question. So let me remind you, what is a container? Go back to the definition. Container is nothing but a kind of process for the host machine. Okay, and to that particular process, earlier in a Docker, you had a user space and then assigned to the network, mount, and PMAP. Remember?
Yeah.
So here, little bit of architecture changes happening here. So here, container do not get IP address. Do not get IP address because container is ultimately is a process. But here, container do not get the IP address. Container get container is a part of the pod, and pod get IP address here. Okay, so pod is
Rajesh,
a kind of.
That's fine. I understand all this, but my question is, one pod has got two containers in it, and they share the same IP address. Say
Right.
one of the containers go faulty or something happens, then how will, in hindsight, how will the API server, the master would know which container is not working? I mean, it could be through a controller manager or whatever, but
Yeah.
a specific container gets faulty. How would it be distinguished from the healthy one? I mean, there should be an identity given to it.
Yeah. So we have a discussion, this discussion pending, and this discussion is pending in the answering the question of what is pod, because remember, I have not explained you what is a pod so far, but just I'm getting you familiar with the pod because I'm discussing about the other component. So now let me go through that and let me reach to the point and then I'll talk about that. Okay.
So is it like pod is having one IP address and the containers inside the pod have a specific port number to redirect the request to?
Right, yeah. So that means if the pod has a multiple containers, they can communicate with each other through the local host. They don't need to communicate through IP address. But if one pod, one container from one pod wants to connect to the another container of another pod, then they have to use the IP address of the pod. Yeah,
so
but
they
again,
are going to communicate with IPC, right? Inter-process communication.
Yeah. So here container do not. I specifically said containers do not get IP address. But the question is, again, this question is not answered so far. What is a pod? And I'm still holding that question. So we'll come back to this.
Okay, Rajesh.
Okay, guys. So now this is the third component of minions. Now look at this here, this very good image. So here you see there's a two host. Okay, in one host you have a three pod, and each pod connected through the bridge, and bridge is connected to the kubeproxy. Now there's one service I have not discussed so far, but I will discuss about. So each node you get a kubeproxy, and kubeproxy manage your bridge, and bridge through that all the pods is connected. So here and other nodes you see kubeproxy on pod. So now this is the way it works. Now kubeproxy basically will help you for many other reasons. We have to discuss L2, L3, and overlay, and many other conceptual things in order to understand the kubeproxy. In detail, we will discuss about kubeproxy in a networking session. Okay, Kubernetes networking, when we discuss, we'll come back to that. Okay, so now this is the three components what you have: Cubelet, which is a main Kubernetes agent in the node, container engine, which can be Docker, and kubeproxy, which is the networking services in Kubernetes, which empower the networking to the pod. Make sense? So guys, overall, this would look like, here you have a master, and here you have a node. Master has a 4 component: API server, controller manager, scheduler, cluster store, and node has a kubelet, kubeproxy, and container runtime environment, which you know very well. Again, kubelet always keep talking to API server, and in kubeproxy also will be communicating with the API server for IP allocations and subnet allocation. So this is the overall architecture of master and node. Did you understand that? Any questions? Now let's discuss about what is a node, and let's sum up. So remember, node has a 3 important component: kubelet, kubeproxy, container runtime. Kubelet monitor API server for changes, responsible for pod and their life cycle, reports node and pod state to the API server, and has also some liveliness probes. Probes means it keep checking the health of the pod. Okay, so that those are the qualities what kubelet has. Kubeproxy, again, network proxy IP table, implement the services. The question is, what is the services? I did not discuss. We will help you. Routing traffic to the pod, load balancing feature is achieved through the help of the kubeproxy. Container runtime, you know that, download images that run containers, container runtime interfaces, Docker, and many others. So this is your worker. Now we do have a many other components also, like a DNS services, ingress services, and dashboard. This we can call it add-ons and scheduled services. So right now I'm not focusing too much on it. Add-ons, we'll discuss on this. So guys, if you remember, we have discussed so far 3 people. Look at this here. We have discussed completely about the master, and now we have discussed about the node, correct? Now we should discuss about the kubectl. Remember, workstation. I again repeat, I'm talking about a workstation which human operates to communicate with the API server. In a workstation, you have a kubectl and you write a JSON file. Okay, so now the question is how this overall it works together. So let's discuss. It's all about the declarative model and desired state. Remember here, earlier we had a evolution of the programming languages like a compiled language. Okay, then we had an interpreted language, compiled language like a Java, C++. And we used to write every smallest to smallest logic actually, and every software we used to write it code, and software development used to take years of time frame. Then we got interpreted languages. Like interpreted languages, you know very well, like it speed up the software development, like a PHP, Perl, Python, and all. It speed up the software development process, but still, there was it's still compared to the today's world, it was consuming lots of time for the software development. So now the world has come to the declarative model. Declarative model, that means where you declare, you don't write a program nowadays. Again, I'm repeating, we don't write a program nowadays. We have the language called DSL, domain specific language. That means we have for every problem we have a specific language, and if you have a problem and just you use that language, it's easy to learn, easy to extend, easy to test, debug, and share. Okay, so that means if you have a specific problem, you have a specific tool, specific DSL language. For example, some of the DSL language you might have used it, like a Maven for the build management, Ant for the build management, Gradle for the build management, for infrastructure coding, Terraform, for change management, Ansible, Puppet, Chef, and like that. So we have so many tools actually, which we have a DSL, domain specific language, which solve the certain problems. Not every problems, certain problems, and that problems it solve it very fast. Okay, so now when we have this kind of DSL problem, DSL languages, then we do not write a program, we declare it. So this tool says, you just tell me what you want, I will get you done. That's all. So now how do we declare it? So earlier we used to declare in a XML, and then nowadays we are declaring in the JSON and YAML. Correct? So that's called declarative model. Okay. So what we declare, you declare where in YAML and JSON. But by the way, API server always receive the JSON. Remember, always accept the JSON format, no matter whether you write in YAML or JSON. Conversion is very fast, by the way. So here now, so you declare. You don't write a program, so don't get scared. You just declare what you want. And once you declare, then you put it in a YAML file, give it to the kubectl. Kubectl will send to API server, will store in the etcd cluster store. Controller will keep checking up, updating API server for the current status, actual versus desired, and scheduler will do the needful things. You know that very well. Whereas in worker, you have a kubelet will receive the request from the API server and do the needful things. So now the question is, you have to declare, but what? You have to declare your desire, and that is what we are trying to learn now. Third important things, how to declare and what to desire. That is the question. What to declare, how to declare, and what to desire. What do you want? Basically, you need to learn only one thing, because Kubernetes will give you everything. So now guys, in the YAML or JSON, you describe your desired state, and you said I need a 3-pod, and you remember one thing, like you need a 3-pod, that's okay, but pod has what? Containers. So container will come from where? Images, right? So basically you express your desire in YAML file, saying that okay, give me 3 pods of Nginx. Now it reaches to API server, rest of the things you know that very well. You got the 3-pod. Simple. 111 anti-affinity. Scheduler has anti-affinity. That means scheduler do not love any specific node. Assign 111. Because of certain reasons, maybe one node got unavailable. Let me tell you here, one node may get unavailable for many reasons, but because of that, desire versus actual is mismatched. No, you had desire, human had desire for 3-pod, which is in the KB store, but in actual you have only 2-pod. Correct? So what will happen? You know that rest of the things, how this controller will report to API server will request a scheduler will assign again any available healthy node for the 3rd pod, and this is the 3rd pod, and actual versus desire is matching. So overall, this is how Kubernetes works. It's all about how you desire, declare in YAML, and then master and worker. Did you understand the flow? Did you understand the flow?
Yeah, Rajesh. Yeah.
Okay. Now the question is, you have understood how to declare, that is in YAML file, okay, or JSON file. But the question is what to desire. That is the question, right? What to desire. You need to learn. Remember, Kubernetes will give you everything. Just we have to spend time on what to desire. What do you want? You tell me. What do you want? You want potato, tomato? What do you want? You will get, you don't have to go to the market to get anything. You will get everything. So in Kubernetes, what do you want? In Kubernetes, what do you want? So Kubernetes, you want the pods. Now the question is, what is a pod? In Kubernetes, you want controllers. What is the controllers? In the Kubernetes, when we want services. What is the services? In Kubernetes, you want storage. What is storage? By the way, guys, this is not exhaustive list. These are some of the key players, key API objects. So you need to learn what do you want. Did you understand that? So you basically, Kubernetes is the kind of orchestration tool. Kubernetes is a kind of cluster management tool. Kubernetes is a container orchestration tool. Kubernetes is the orchestrator for the microservices. Kubernetes will help you to match the actual versus desire state, whatever you have, it will help you to match it. but you need to only learn what you want. You have to tell to the Kubernetes. And the first element what you have in the Kubernetes is pods. So can we go ahead and know that what is a pod? Okay, so what is a pod? So
It's a
pod
wraparound
is a
container.
yeah. So pod is a atomic unit of scheduling. So understand this way, guys. See, you all have used the virtual machines, hypervisor, VMware, VirtualBox, Hyper-V, Zen, KVM, and many more. So when you say, let's say VMware, you want to create at one unit of compute unit. So what do you want? So typically in the VMware, you will create a VM, correct? Simple. You will create a VM. Inside a VM, you will have operating system. That's a different thing, but at least you will start with a VM. Without a VM, can you have operating system? No. So for VMware, the atomic unit of scheduling is the VM. Now the question is, when you go to the containers, Docker, okay, Docker. So when you say Docker, you want the compute unit, you want to run some application. So what do you create in a Docker? Container. Now what is a container? I'm not getting into it, but you know that very well. Docker manages container. VMware manages the VM. So on same logic, guys, Kubernetes has no idea about VM and has no idea about the container. Understand that? Yes. So Kubernetes has no idea about the VM. Kubernetes has no idea about the container. Kubernetes, the atomic unit of scheduling is pod. That means if you are working with the Kubernetes, and you want the compute unit in a simple way, if you want to run some application with the help of the Kubernetes, you have to create a pod. So pod is a atomic unit of scheduling. Make sense? Make sense?
Yeah.
Yes. Now the next question is, guys, understand this way. One more thing. Understand this way. Have you come across any time where VMs hypervisor companies stated saying that you can only install only this operating system? Have you come across any time that hypervisor company is saying you can install only this operating system or only that operating system? No. So VMware or any hypervisor has never stated saying that you can only run this operating system. This company says you can run any operating system. I don't care. I don't care. So what I will manage as a hypervisor, I will manage the state of the virtual machine. Inside the virtual machine, what you have, I don't care. I will only manage the state of virtual machine. Now same logic you apply in the Docker also. Have you come across any time Docker stating that I will only run this image, or I will only run that image? No. Any images which you have, Docker can run it. Cool. So same way, same on the same line, Kubernetes also never stated saying that inside a pod what kind of container you can run. Yes, inside a pod, Kubernetes manages the state of pod. Understand that? Kubernetes manages the state of pod. What is the content inside the pod? Kubernetes don't care. Kubernetes don't care. So here, what I'm trying to tell you here is VM hypervisor companies manage the state of VM. Docker manages the state of containers the same way. Kubernetes manages the state of pod. Okay. Third statement, guys, when the VM is running, and I have discussed in the Docker session also, when a VM is running, when your PID1 is running, remember Yes, your VM is running as long as the PID1 is running, and here in a VM you have operating system. Because of that, PID1 is your system D. System D is running in the daemon mode, so that is not exiting, so your VM is running. When you shut down, that system D gets exited and VM get exited. In a container also, you know very well, in a container we do not have any operating system, so where the PID1 can be anything. I told you very clearly, in the container PID1 can be anything, but as long as the PID1 is running, container is running. That PID1 is not running, container is not running. That means here VM is running as long as the PID1 is running, container is running as long as the as long as the PID1 is running, pod is running as long as container is running. Okay, so what I'm trying to tell you, overall, VM is a atomic unit of scheduling for the hypervisor. Container is atomic scheduling of the Docker. Pod is atomic unit of scheduling in Kubernetes. VM do not care what operating system you are running inside it. Docker do not care what images you are running inside a container. Same way, Kubernetes do not care what kind of pod you are running inside, what kind of container you are running inside a pod. Hypervisor manages state of VM, Docker manages state of the container, and Kubernetes manages state of the pod. VM is running as long as the PID1 of your operating system is running. Container is running as long as the PID1 of your images is running. Pod is running as long as all the container is running. Is that clear? Did you understand a little bit of the pod right now?
Yes, Rajesh, very clear now.
Okay, so now let's understand that.
Rajesh, one question I have. So if a pod has two containers and one container gets killed, so that does not impact the pod, right? So when you say
It will impact.
when
It
container
will impact the
is not
pod.
running, pod is not running, right? So in that case, pod
Yes.
will be not running.
No, so it will try to, that pod will throw you an error. It will try to restart the container for your answering your question. And if it is not getting started, pod will not be stable. Pod will not be running state. It will be an error state. So that I will come back in some time.
Rajesh,
Okay. Yeah.
means the scheduler directly connection with the pod, not in a container, right?
What is that, sir?
Yeah, a scheduler directly connection with the pods only, not a container, right?
No. Scheduler only schedule. It's like a supervisor. It's like a manager. Schedule to the kubelet, which is running in the each worker. The managing of the pod is been done by the kubelet. Remember, kubelet is the main Kubernetes agent which is working in the each node, and pod is managed by the kubelet but reported to the API server, so rest of the component will know about this guy.
So, means the kubelet have a connection with pods, not a container, right?
Yes, kubelet manages the pod and then request the Docker, boss, you go and fill that inside a container. So kubelet ask for help to the container in that case. Okay guys, so yes, now we'll discuss little bit more about pod. So yes, container always run inside a pod, and pod can have a multiple containers. You see here, pod get again understand that pod get a network namespace and mount namespace. Here container do not get. Remember in the pod in the Kubernetes in the Docker discussion, I used to tell you a lot about network and mount. Here all the kernel namespaces, here pod gets it, not containers gets it. So understand that all containers in a pod, understand that all containers in a pod share the pod environment. That is a thing. So now if you have a pod with the two containers, that is called tight coupling. Sometimes what happens, your developer would say, no, I need to run these two applications in one virtual machine or one container, or if you're migrating to the Kubernetes, then it has to be pod. In that case, you can run two containers in a one pod. That's called tight coupling. Typically, we run one container per pod, because one application we can run inside a one pod. This is called loose coupling. Okay, now you see here there is a one pod one container which is to be corrected, and one multiple container one pod which is wrong. Why? You any idea why do you think so it's wrong, and what is the why it is right?
Because port is not only
Yes,
one
so
port, right? So
ultimately remember one thing, why we are learning Docker and Kubernetes. We are learning just to save our CPU and RAM, storage capabilities, compute capabilities, and to getting at speed. So remember, here you are running 5 Nginx, that's okay, but load balancer only load balance one of each, right? Not for all 4. So here you are wasting resources actually running the 4 containers on a different port also. So that's not a good practice. If you are running one application, you can run in a only one pod, not two same application you should run in a one pod. That is a not good practice. Okay, now when you have a 2 containers in a pod, first container we call it main container. Again, I am telling you, once we have a 2 container in a pod, first container we call it a main container, second container we call it a sidecar container. Okay, so now here pod are atomic, and pods get every namespaces, and all the containers inside a pod share the same namespaces, sidecar and main container. Now here pods can be scaled. When one pod is there, you can get another pod. So it's like that. You have a one pod, other pods you want to create of similar nature, then from the ready it'll become a pending state. So here ready to pending state. Now you see these are the life cycle of the pod. First, whenever you create a pod, Cubelet create a pod, remember. So from the here it will go to the pending state, then it will become a running state, and it may go into the succeeded and failed also. If your work of the container has been completed or pod has been completed, it may succeed or may fail. For example, let me tell you in what scenario it may fail and for what scenario it may succeed. For example, you run docker run ubuntu ls. So ls is like a kind of real executable which you found in the ubuntu image. It will run it and it will get exited. That is called succeeded. Now when you say docker run ubuntu xyz is not an executable which you can find in ubuntu image. In that case the runtime will be failed, so that is called failed pod. So remember in that way. Okay, so here yes, now in a pod you have a 2 containers, and both the containers you can run on the different port, and from outside you can access it the IP address of the pod. That is the way you can access from outside. Here you have a 2 container. Good practices is being called as a 1 container 1 pod. So here you see the different 2 pod. You have pod 1 and pod 2, and you have a different IP addresses also. Now here pod one container is a good practice which is called inter-pod communication. So all the pod communicate through each other through the pod network. Remember, all the pod can communicate with each other through the pod network, and this pod network is been managed by kube proxy, which is the networking services which is there in each node of the cluster. Remember, that is the things which we have to discuss. Okay, now you see here both the containers inside the same pod can communicate with the same local host, but from outside they have to communicate with the IP address and then port number. It's just typically like a VMware, a VMs and a container. Okay, so now the question is, what is a pod? Yes, so pod has one or more containers. It is your application or could be a service. What is a service? I need to discuss about this. And the most basic unit of work, unit of scheduling. Again, it's infernal. No pods ever redeploy. Again, I'm repeating this line. Pods are infernal. That means same pod you cannot and you can never redeploy. Okay, so you will get a new pod, but not the same one. And atomicity, they are not there or not there. Okay, again, Kubernetes job to keeping your pods running. Understand that. That's the job of the Kubernetes. Ultimately, you know that Cubelet is the real worker. More specifically, keeping the desired state, health, and liveness probe. So basically, Kubernetes job is to keeping your pods running. In terms of state of the pod, it should be up and running, and the health of the applications, it should be good, and liveliness probe. So all these things is been done by Kubernetes with the help of Cubelet. Remember, Cubelet is the real doer here. But Kubernetes overall, when I say Kubernetes, like API server and scheduler and other things which manages stuff. So guys, this is the pod, all about the pod. Any questions? Anytime?
During the network slide, right, Rajesh? So in
Yeah.
the network slide, we were having 3 rules. So if I remember, the first rule was all pods can communicate to other pods, right? So
Yeah.
that
So
is
all pods,
that applies for internodes or intranode.
yes. All pods can communicate to all pods in all nodes. All nodes can communicate to the all pods in the all nodes and without NAT. How that is possible? That is being done possible with the help of kubeproxy. Kubeproxy is the networking services, load balances the pod,
Mhm.
assign the IP address to the pod, and doing many other things as well. But right now I'm not deep diving into the kubeproxy, because of when we will discuss in the networking session of the Kubernetes.
So I just wanted to clarify that one pod 1 from node 1 can communicate to pod 2 of node 2. Is
Yes,
that
why
correct?
not? Yeah, that's possible. No,
All,
that's the job of the kubeproxy, right?
all right. Okay.
Remember,
Yeah.
all pods can communicate with each other on all nodes. So why not? That's done by kubeproxy. How that is been done by kubeproxy? We need to discuss about L2, L3, and overlay networking, Kubernetes networking interfaces and all.
Rajesh,
All right. Okay.
Yes.
Thank you.
yeah. So if my Kubernetes infrastructure is shared across multiple teams, so I understand the statement you says all pods can communicate on all nodes, but
Mhm.
can I stop that because of security
Yes. That is true.
concern, it can be imposed
That
as a yeah.
Yeah,
Okay.
that is a possible. So here I'm talking about the right now clustering. You are talking about the sub clustering, dividing the one big cluster into smaller department or team. So that is possible.
Exactly.
And yeah, so once
Yeah.
we get into the demo and stuff like that, we'll show you that. We call it
Okay.
namespaces actually.
Okay. Thank you.
And regarding the liveness probes, so is it the probes check whether the pods are in a healthy state, or whether the
Yes.
Docker containers, each of the Docker containers are in the healthy state?
No, this is set. This is done by Cubelet. If you remember here, Cubelet, which helps you to the pod liveliness and props both. So Cubelet, once you inform a Cubelet, he will keep doing it. It's like a giving an instruction to the Cubelet saying that, okay, you keep doing, keep monitoring this one, and Cubelet will keep monitoring this one and will informing to the API server on it.
But who does the container props actually?
Containers probe. Okay, so here pod liveliness one probe is done by Cubelet. Containers probe cannot be done by Cubelet. For that we use a C advisor. There's a different tool actually, we have it, and which is not a part of this program, but C advisor is the one tool which can be used for the containers monitoring.
Okay.
C advisor means container advisory. Yeah, tell me more questions, guys.
So that C advisor you have to install on as an agent on all the nodes.
Yes. Each node has to have a, remember, it's all about the containers, and containers is nothing but the resources on the physical in the virtual machine or physical machine. Associate advisor can monitor the each of these
Mhm.
containers part of the C group, so they manage it. So yes, that is there, which is not a part of the CKA
And
certification. But if you want to
mhm.
bring the Kubernetes into the operations and all, then it is a part of it. This Kubernetes infrastructure monitoring and monitoring, logging, and all security related topics at the orchestration level. That means like Istio, service mesh, and stuff like that. These topics is a part of the MD course, like Master in DevOps Engineering. So I think some of you are already part of it, so you'll be having that session.
All right, Rajesh. So that C advisor will report the status prop data to API server, if I'm not wrong.
No. C advisor can be you have to run the C advisor at every nodes, and it will expose all the matrices about the containers at certain endpoint of your each node. Now through Prometheus or some other tools, you can scratch those matrices and then do the analysis based on it. So it has no
All right, okay.
relationship with API
With
server.
API.
Others will become a lots of burden on API server, right?
All right, yeah. Thanks for clarification. Yeah.
Rajesh, so in each node, there is a Docker daemon running, right? That's what you're calling Docker
That's
engine.
correct. That's
Yeah.
correct. Yes.
How we define and where which version of Docker daemon it is running. So if there's a new version of Docker came in and we want to update, then how on a running train where we can do that? Is it how we do
Okay.
where
So
we define?
first of all, you cannot keep on running. If you want to upgrade your Docker daemon or Cubelet, you have to make the Cubelet, that node, offline. Now Kubernetes has a provision to make the nodes offline, and in that case, what Kubernetes will do, the let's say the number of pods which is running in a certain particular port, they will drain it out to and give it to some other nodes, and meanwhile you can upgrade whatever you want. So that is possible. That's not a problem. Those are the things can be doable through the Kubernetes itself.
Okay. Okay. Yeah.
Okay. Any last question? Who's going to ask last question, guys?
A queue proxy will be the part of all the node, right? It will be also running
Yes,
as a
that
agent on all the
yeah,
nodes.
that would be a part of every nodes which we have, including the master node. But right now, I'm not confusing you too much, because slowly, if I reveal the information, then it will be now as part of your understanding. So yes, I'm not confusing you, but yes, queue proxy will be part of the every node which of your cluster.
So Rajesh, is the master node kept in a pod as well?
Master node is yes, you got this architecture very well and very right. Actually, remember, it's all about applications. These all components which you see is applications. So why can't we run in a pod? Because Kubernetes ask everyone else to run application in a pod. So why they cannot run their own application in the pod? So yes, to be honest, these all are pods actually, except two things here: container runtime and Cubelet. Okay, apart from that, everything is a pod. But yes, again, that topics I'll come back to the next session slowly, because I don't want to create a complexity to begin with.
Yeah, I admire this approach. Now the understanding of Kubernetes architecture is becoming clearer and clearer after every session. Yeah, I'm enjoying it. Thank you.
Okay, guys. So yeah.
Sorry, is there any template for the JSON or the YAML file from the kube controller we
Yes.
write?
We have a YAML file, JSON file. We have a template. I will give you that template. That's easy to write, easy to read, easy to share, easy to debug, and we will do that stuff. That's, I think, that we'll do in the sixth session, because next sessions I'm going to discuss about the services, which is the most important one, and deployment. And after that, I'm going to set up a cluster, actually production grade cluster, and then after that, I'm going to introduce you the YAML file.
Thanks for watching. To watch our complete session, enroll for our premium membership. Click onto the join button and enroll yourself with the best suited option.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Want to study further? Subscribe to our paid membership to get a deep dive into each and every topic. Do look out for more videos in our playlist and subscribe to our DevOps School channel and hit the bell icon to learn more. Keep learning.